Okay, you have to refer to the graph on page 234. You see the graph? Yep. They say lie within one standard deviation either side of the mean. So that means you are looking for this area. Mean minus one standard deviation, mean plus one standard deviation. And if you look at it, will be 34.13 plus 34.13. Are you okay? So it doesn't matter regardless of the standard deviation or the mean. Okay. So therefore, part A, probability of the variable X within one standard deviation away will be equal to 0.6426. That's it. Okay, then they say it's more than 2 standard deviation above the mean. So that means if you refer to that page, 2 standard deviation above this part. So this is mean plus 2 standard deviation. Are you okay? So the probability of X more than 2 standard deviation above the mean. So that means mean plus 2 standard deviation. Okay, so okay, so 2 plus mean plus 2 standard deviation. So you refer to your graph, it will be 0.0215 plus 0.0013. So the answer will be 0.0268. Yes, 68.26. Yeah. You have to send Miss Doe to primary school already. 68.26. Yes, you are right. Okay, so this one will be 0.0228. Okay, so can or not? So that one all have to refer. So it's regardless of the mean or the standard deviation. It's standardized like that already. As long as it's a normal distribution, as long as it is one standard deviation away, the probability will be like that. 2 standard deviation away or more than 2 standard deviation from the mean, the probability will be like that. Yeah. Is that okay? You have to define the variable. Okay. Jason's oranges. Okay. Now, and he said it's normally distributed. So in this case, he said it's normally distributed, but we don't know what is the mean. This is a question mark. We also don't know what is the standard deviation. Okay, but the question does give us the percentage, that means the probability. They say 84% of the crop weigh more than 152 grams. Okay, so that means probability of X more than 152 is equal to 84%. That means 0.84. If you go back to the graph on page 234 again. So 84 is above 1 standard deviation from the mean. 84, so is 14, correct? 16. So 16 is here. So here is mean minus standard deviation. So this is 0.84. Agree? So that means this is your 52. 152. Okay or not? Okay, student, that is how I understand using the graph on page 234. So now I have one equation, that is mean minus the standard deviation equal to 152. Okay, now second equation comes from the other one that state that, okay, and 16% way more than 200. So probability of X more than 200 is equal to 0.16. So if I draw a graph for this one, more always go to the right. This is, sorry, this is 0.16. So this is 0.16. So if you go back to the graph again, 16 is, here is mean plus 1 standard deviation. So that means now I know that this value is equal to 200. Okay, so now I have two equations. Mean plus 1 standard deviation is equal to 200. So now I solve these two equations. I add them up. Okay, I add them up, so I have 2 times the mean. 2 times the mean is equal to 352. So the mean will be equal to 176 grams. After you know the mean, you can put into 176 plus the standard deviation equal to 200. So the standard deviation will be equal to 24 grams. You get me? That is how you use the graph on page 234 to help you. Now, is it fine with you? Okay, this question, I also can do it with my graphic calculator. Okay, but I have to know something else before I can do it with my graphic calculator. Okay? Okay, you take 2 subjects, EAL. Okay, that is, so my X variable is EAL. Huh? Okay, he got, this student A got, okay, 80 marks for EAL, for example. Then for maths, okay, I use variable Y. He got 52 marks only. Okay, now, can you say that this student A performed better in EAL than in maths? You can't, because you cannot just base on the raw score, because we don't know how easy is EAL paper as a whole. We don't know how difficult the maths paper as a whole. So we need to have some more information. Okay, so we assume that EAL and maths mark all are normally distributed. And EAL, the mean is 82. The standard deviation is 5. For math, it's also normally distributed as a whole with the mean of 53 and a standard deviation of 10. Okay, so now, just based on this, can you tell me that this student performed better in maths or performed better in EAL? Both are above the mean. In EAL, he is 2 marks above the mean. And in maths, he is 1 mark above the mean. So can I say he is better in EAL than in maths? I can't, because standard deviation does make a difference. So if I want to know, if I have a graphic calculator, I want to know he performed better in which subject, I find the proportion, or I find the proportion of people in this group which is performed better than him, or perform worse than him. So can you find? So now we find how many percent of the, he is the top, how many percent? So for this one, we'll find the probability that how many, what is the percentage of people that is score more better than him in EAL? So can you please take out your calculator and start to calculate? And also perform better than him in maths. Then now we can make a comparison. Oh, sorry, EAL is, sorry. Can you change? Sorry, my mistake. This is okay. Never mind. Let this be 82, and let his mark be 84. Let his mark be 84. Yes, you are right. Obviously, I'm saying something that is wrong. Yeah, you put 84. So can I have the percentage? Sorry. I'm right just now. It's 2 marks lower, not 2 marks higher, okay? So just remain as 80. Okay? What is the answer? You go to second distribute, normal CDF, lower 80, upper 10 to the power of 99, and mean is 82. 2 marks lower, not 2 marks higher. Standard deviation is 5, then paste. Oh, you get a problem, huh? Okay, sorry. I make something, some error. Okay. So you get this as 0.6554. Yeah. Then the other one. (53), 52, sorry, 52. I think I'm not right. And here is 53, and here is 10. Okay, and you got 0.5398. So now, based on this, you tell me, okay, student A perform better in maths or perform better in EAL? Can you tell me, perform better in maths or perform better in EAL? In EAL, he got 65.54% is better than him. Okay, and in maths, only 53.98%. He's the top 53.98% is better than him. So that means this student perform better in maths. Now, if I don't have a graphic calculator, I can't find. I don't have a table also, I can't find. So what can I do? So this is what we call in maths, in statistics, what do you call scale score? Yeah, listen here. I'm going to draw the both diagram for you. So all these are normally distributed. Okay, so this one, the mean is 53. And this one, the mean is 82. Okay, all this score, we are going to scale it to what you so-call the standardized score. Okay, when you say standardized score, that means this is a special normal distribution. The mean is 0, the standard deviation is 1. That means the mean here, it coincide 0. Got it? Okay, so if X is 87, then the standard score will be 1. If X is 1 standard deviation above, 1 standard deviation down, then the standard score will be -1. That is, you take your calculator, 82 minus 5. That is 77. So on and so forth. This is 92. This is 92. 92, the standard score will be 2. 97, the standard score will be 3. 72, the standard score will be -1. Are you clear? That is how you go. Okay, then for maths, 63, the standard score will be 1. 73, the standard score will be 2. 83, the standard score will be 3. Okay, so when 43, -1, 33, -2, and so on and so forth. So now, that means there is a formula for us to find the standard score. If you have a look at it, if 82, it becomes 0. If 53, it becomes 0. So that means every time when you do this kind of thing, you find the standard score. This is called standard score. So Z, we call it the standard score. That means I can't compare two raw data, but I can compare with their standard score. So now, so the standard score formula will be the variable itself minus the mean divided by the standard deviation. So any standard score can be found using this. So now let's look at his EAL standard score. That is, look, I take his score minus the mean over 5. So what do you get? What do you get? 2 divided by negative 0.4. Am I right? Then for student A max score, the standard score, okay, I will put it as 52 minus 53 divided by 10. So I get negative 0.1. So standard score for max is higher than standard score for EAL. So therefore, this student performed better in max than in EAL. So please bear in mind, if you find that during the final exam, correct, the paper is very easy, correct? Okay, you don't be so happy. Why? Because everyone can perform. If the paper is difficult, okay, yeah, everyone say it's difficult, not you only, be careful. If the paper, everyone say is difficult, then you find that you have very few questions that you don't know how to do. So bear in mind, you may get a good standard score. But usually I can guarantee you for sales paper, correct? Most of the paper, they are quite standardized one. They won't say that one paper, one subject is easier than the other subject. Okay? So now you know what is the purpose of us study standard score, so that you can make a quick comparison. You don't have to find the probability. So is this formula important? Yes, this formula is important. Clear? Now, do you know how to find the standard score for everyone? So now, we have a variable X, that is the weight of Jason oranges. They tell us it's a normal distribution. We don't know what is the mean. We don't know what is the standard deviation. Okay, but we know two information. This time I draw the graph. 152, the area is more than 152. So I shade this area. Okay. More than 200. This area is 0.16. Okay. So now, every X value, there is a corresponding of standard score Z1, am I right? Standard score. So I call this standard score Z1, I score this standard score Z2. Now, can I find the value of Z1 and Z2? Can I find the value of Z1 and Z2? The answer is I can, because I know the mean and the standard deviation of standard score. So therefore, Z1 is equal to, can you please take out your calculator and tell me what is the value of Z1? Same go with Z2. Still remember, we want to find the standards, we want to find the value of the variable, we have to use inverse norm. Area, mean, standard deviation, and this is area to the right, select right. Can someone give me the Z1? Hello? Yeah, you get negative. So your calculator give you a very exact value as compared to your graphic calculator, 0.999999445. So a lot of things in the graph on page 234 is approximate value. Okay, can you give me Z2? This is 0.99445. Am I right? Okay, so now, how do we convert X score to Z score? Still remember the formula? So from these two information, make two equation. Yep. So I'm going to get to the next page. Or I should put it here. So I have negative 0.9945 is equal to, my X is 152. Standard mean, I don't know. Standard deviation, I don't know. This is 0.9945445 equal to, the X value is 200. Mean, I don't know. Standard deviation, I don't know. So you solve for your mean and standard deviation now. So you should get the same answer as what you have just now. All right? So I have the two equation, negative 0.99445 times by standard deviation equal to 152 minus the mean. 0.99445 times by the standard deviation equal to 200 minus the mean. Okay, I add these two up. So I got the mean and the standard deviation. Are you okay? Okay, so now I want to tell you why we need to learn the Z-score. Since we have the graphic calculator, correct? Why? So first, I can make a quick comparison. Even without graphic calculator, I can make a quick comparison. I can straight away, you can tell me the raw data, you tell me the mean, you tell me the standard deviation, and I assume the distribution is normally distributed. Okay, so I straight away can tell you the standard score. And I compare the standard score. That is only fair. That is called standardized score. All right. Another reason why I must know the formula is because if I need to find the mean or the standard deviation of the distribution of any normal distribution, what should I do? I definitely have to get the help of standard score. If not, I'm not able to find. If they didn't give me a nice value like 1 standard deviation away, 2 standard deviation away, they give any other thing, then I can't. I have to get the help of a standard score. I find the corresponding standard score using the formula of a standard score, then I try to get the value that I wanted. Are you clear?